So we're going to start the workshop with our first speaker of the day, Anton Coetzee, and he's been working a lot with CIDOC-CRM and ontologies, and especially CIDOC-CRM, and he's going to talk to us about ontologies and heritage, and he will give us an introduction to CIDOC-CRM. Anton, if you can unmute yourself and share your screen.
Fantastic. There, let me share my screen. Let's see if that's going to work. Okay.
Perfect. We can see your screen. Yes.
Excellent. There we go. Okay. Good morning / afternoon, everyone. Again, thanks to Zade and Stefania for inviting me to speak on this. And I kind of hope that for those of you who are familiar with CIDOC-CRM, bear with me for the next 20 minutes or so. And those of you who aren't, I'm really hoping it can shed some light on the schema that basically informs the underpinnings of the Arches platform as used by MASA and MAA-SAM. So I've kind of worked this to hopefully then dovetail with the practical exercise later on. We're playing the CIDOC-CRM game. So I might not be going too deeply into some aspects of it, but hopefully it would at least provide a basic introduction as to how this whole thing works. Okay, so we are all familiar with the ongoing discussions of metadata in discussions of digitization and archiving and the usual problems, in that much material is unfindable and inaccessible. We have things, that are unavailable because they're, well, some of it talks to the longevity of archival platforms and funding, which we all know about, and things that are badly classified or don't have sufficient or adequate metadata, as there's no point in having all of this digitized if we can't find what we're looking for and make use of it productively. And I'm sure you've heard of the FAIR principles: findable, accessible, interoperable, and reusable. So not just allowing us to find what we need in our data, but allow others who may or may not be familiar with our organizational schema or workflows to find things and reuse our data productively. So more digital data, that is data that originated in the digital domain, spreadsheets, digital photographs, and so on, is already searchable to a limited extent. But what about legacy data, which I think MAA-SAM and MASA are dealing with a lot? Site reports, photographs, tracings, plans, historic maps, narratives, and how these can be integrated into platforms. And for instance, things like marginalia, in catalog cards, in site reports, people scribble things in the corner, people refer to other documents. And much of this gets in traditional methods, traditional schemas, such as Dublin Core, for instance. It gets either left behind or flattened into a generic field like additional notes or something to that effect. So are there ways around this? So the idea of an ontology. So many of us might be familiar with the ontological turn in anthropology, the work, for instance, of Viveiros de Castro and Strathern, and the idea of, as Smith puts it here, the science of what is, of the kinds and structures of objects, properties, events, processes, and relations in every area of reality. Basically a full catalog of the world and all that is in it. And so this is something that, philosophers have been working with for hundreds of years: John Wilkins, Leibniz, and so on, the true catalog with a capital T. We could call that a top-level ontology. So there's a pivotal paper published in 1991 by Thomas Gruber connecting these fields, collecting the field of philosophy and that of knowledge organization, that is classification systems and schemata and so on, connecting these two things. And the idea with this was to assist in the sharing of knowledge across dissimilar archival and classification systems. And importantly, to allow for semantic interoperability. So the way Gruber puts it is, it's not just the ability to exchange this data, but to understand and interpret the data across different platforms in a way that retains its meaning. So basically, the fact that its meaning must remain clear, consistent, and unambiguous as it shifts between systems and platforms and collections and catalogs. So particularly given the nature of these projects, MASA and MAE-ASAM, and obviously being in the Global South, this is something that I'm particularly interested in working with, is that an approach like this could be seen as a response to the reductive and very Eurocentric nature of traditional classification schemata. On the one hand, we have this, in order for interoperability between platforms across the world, across nations, across cultures, there is a need for universalism and flattening into common descriptions, common vocabularies, versus the need for specificity and cultural, I suppose, cultural sensitivity, you can say. And so I think the ontological approach affords us that option. So then secondly, the principle is we can define not just what a thing is using this, but also its entire position within networks of people, places, events, and other things. And it's a very Latourian thing. We can afford objects some agency, and we can look at where they sit, not just as isolated objects or as isolated things, but in a much larger picture. And Duer, who is one of the people behind the CIDOC-CRM, I think put it very succinctly when he mentioned the notion of information integration, which must break up document boundaries and relate contained information to a wider context within the archive. And I think that idea of breaking up document boundaries and taking the information outside of that document boundary and connecting it to all other things is actually quite powerful. And as a result of that, so firstly, that needs us or affords us the ability, but I think it forces us to, in fact, to develop an internally consistent model of the domain that we're working within, and to consider the nature of the networks and that within that domain. So it really is a much deeper exercise other than just metadata and how to describe an object. And what we are also seeing here in the way this works is we are seeing this entanglement, this inextricable entanglement of metadata and data now. It's becoming very difficult to disentangle them and say, well, this is just data, this is what describes the data. Okay, so that's maybe a little bit of material for those who are interested in the theoretical and philosophical side of it. Let's get down to some practicalities here. So what is the CIDOC-CRM? So this is developed by International Council of Museums, International Committee for Documentation. It's a mouthful. We'll call it CIDOC. CRM means Conceptual Reference Model. So the CRM does not attempt to be a top-level ontology, i.e. does not attempt to describe the entire world. Neither does it pretend to be a pure domain-level ontology, in that it describes a very specific field: archaeology, museology, intangible heritage, and so on. It sits somewhere in the middle. As Becchiari asserts, the aim is not to capture in a structured form everything that can be said about an item, but to focus on the high-level entity and the relationships needed to describe data structures. So the containers that hold the data and how these things in these containers relate to all other things. So as I've mentioned earlier on, in the concept of ontology in general, it does offer the potential for breaking away from the baggage inherent in traditional documentation systems. What I see as so encouraging is the MAE-ASAM and MASA and the involvement in the Global South, because most of the development of these systems generally happens in the global north, particularly CIDOC-CRM. But I think there's pressure and lots of development and interest and knowledge coming from the global south now, and fomenting change within these systems. Okay. Another reason, I'm skipping around a little bit here, I apologize. Another very good reason to be using the CIDOC-CRM, it is now an ISO standard for cultural heritage documentation. I think it's quite important that it's not perfect. It's a bit complicated, but it's now a standard. It was originally designed for museum collections and working across and within museum collections. And as such, it focuses on context and provenance and events underpinning that, ownership, acquisition, disposal events. And I will talk a little bit later about extensions to it, which deal a bit more closely with, in this case, because we're dealing with archaeology primarily. As it is flexible enough to work across various domains. And the core model is deployed widely in these, but it does have these tightly focused domain-specific extensions, which I'll talk about in a bit. So here we see, just as an example, there are many more. There's a link. I will share this presentation if anybody wants these links and readings later. There's CRM Geo, which deals with spatiotemporal models, time span, space-time volumes, and refines the event model, which I will talk about in a little bit more. There's CRM Archeo, which is designed specifically around archaeological excavations and the concept of the Harris matrix. There's CRM Dig, again, I think of interest to this group, for digitization activities, paradata digitization processes, and derived digital objects. So we can keep the paradata and develop the paradata involving people scanning or digitization events, people involved in the events, the equipment used, the settings used for the equipment, the original data sets, things created from those data sets, and so on. So again, there's a link there with all the other extensions. There are quite a few of them, so take a look at that at some point. Okay, and some shortcomings in that it's complex. It's very complicated. It takes a while to get your head around the details and how it works. And as Haji Gozella et al. Have talked about, transcribing or annotating unstructured and generally legacy material is very time expensive. And I'll give a little example of that in a bit. Okay, so some key points about how it actually works. So it works on this idea of subject, predicate, object. A thing, a property, another thing. And I'll show an example as to how that works in a bit. It's easier to see it actually in practice. It's event-based, working with events at human scales, like not geological time. There are two components, classes and properties. So classes loosely represent things. They can be physical or conceptual things, while properties describe these things and link them with other things. It's a hierarchical model with a hierarchy indicating broader concepts to narrower concepts. So we have classes and subclasses. So a class describes a general thing. A subclass will refine that concept. But again, we'll see that in the examples. And I like to think of properties and relationships, well, the properties, as opposed to the classes, as relationships or pathways. And it's useful to think of it in this way rather than the traditional models of metadata where you have fields for things. You would have a field called title, a field called current keeper, a field called type. And again, this will hopefully come clear as I demonstrate some examples. I'm not going to go too deeply into this. I'll just leave this if anybody wants to look at the presentation later, just talking about the general arrangements of the classes and subclasses. So the classes are all named E's as in entities. The properties are all named P's or begin with prefixed with E's and P's. Numerically, unfortunately, they're not in order. They do not reflect the hierarchy because they've all been added over many years. So everything is a subclass of the E1 entity, a thing. We have E5 events, which is another very important thing to be remembering. We have E77, which is persistent items, human-made things, symbolic objects, and so on. And we have E39 actors. And those are kind of the important top-level ones. Again, I wouldn't expect anybody to remember this. This is where the documentation is your friend. So a quick example here. This is a museum object. This is all transcribed from index cards in the accession register and catalog. Very simple. It's got all the fields that we recognize, description, type, who holds it, its accession number, and so on. So here I have visualized it just in a quick diagram using the CRM. So here I've represented it as an E22 human-made object. That's its class. That's an entity. These are either entities, other classes, or other instances of a class. We have the group, posited in Intel Museum, an identifier, its accession number, and type part. And now these are the properties that we're talking about. The properties, we can think of them as relationships with other objects. And we can think of effectively dealing with these as a set of pathways. So P50, it has the current keeper, posited in the Intel Museum. P48, its preferred identifier, is accession number in this case, and it has the type of E55 type part. So jumping back a little bit, here's a little excerpt from the documentation. And so if we look back at that, we'll see, I actually don't have that there, so I'll skip that. So anyway, this is how the documentation describes each, in this case, a property. So we have P1 is identified by its domain and its range. So when we look at domains and ranges, basically the domain can be whatever can connect, whatever class of object or type of object can connect to the base of that arrow. Its range means whichever object can be at the point of the arrow, i.e. domain, what it can belong to, what type of thing it can belong to, and range, what type of thing it can relate to. And those are quite important, as we'll see when you do the practical exercise of the game later. Not everything can have every relationship with every other thing. There are very tightly constrained things, and this is how we structure how the data is structured. The other thing that is quite important is the scope notes. If at any point you have a problem, go and read the scope notes. They're very complex, but they are very detailed. There's been a lot of thought put into developing those. Okay, back to the example. There's our object. I've added another link. P1 is identified by an appellation. So this is pizza, which has the language of Tswana. So it affords us the ability to add links to, and we can have as many of these as we like attached to this object, for instance, in many different languages and so on. I realize I'm running a little bit tight on time, so I'll accelerate without hopefully skipping anything. Here's the object. I've added some more links to the object. There was an activity, the excavation of the site. There is a place. It could also be a site. Green Acres Farm. Now, this is quite useful. We can also have not just relationships with other objects, but relationships with, in this case, what we call a space primitive, with a value which in this, which in this case is a geospatial set of geospatial coordinates, a boundary, a string in WKT format, and so on, which defines a point or a region or something in geospatial terms. So that, for instance, can be pulled straight out of the database and mapped. So that defines the place Greenacres Farm. And also, turns out Greenacres Farm is contained in a larger place, in this case, possibly a district called Greenacres. So as we see also, things can get very complicated very quickly with your relationships, but also to understand that not all of these relationships are necessarily hand-built, if you want to put it that way, in ingesting objects into the database. Many of them are automatically discovered, depending on geospatial relationships and other relationships, kind of emergent relationships, when multiple things are ingested into the database. Here we are bringing a person in now. So here the activity excavation was carried out by this person. This person has type archaeologist. And so then I was going to jump to the overview of everything I've built here. So there we go with the object in the middle and all of its relationships. And this is all effectively from the point of view of this object. Now, it's important to bear in mind in an archive, in a database, each of these things will have its own cloud. If we want to look at it in this context, will have its own cloud of other relationships. So there are things that carry on from archaeologist, from KwaZulu-Natal Museum, from POT, from Tswana. There's this web, this network of relationships that goes out from there, so that the object, we see the object is not just an isolated thing in the database. It is entangled in this massive network of everything else in the database, in the archive. Okay, just to then, so that was as an example, was an artifact in a museum. A lot of our work involves historic sources, narratives, travel guides people have written in, in the 19th century and so on. And so often we will be using narratives. And so here, just based on some work by, again, Pereira Hadjikozela et al., the idea of annotating, just as an example, it's quite a nice way of figuring out how these things might work. So this is an excerpt from a site report. Just a little paragraph. And this is, I've annotated it as to how it might fit in within, how we might break it down into, and basically enrich the data now, how we might break it down to fit within the CIDOC-CRM. We have physical feature, excuse me. So these are entities, these are properties. Physical feature falls within, human-made feature, and so on and so on. So again, I'll leave this there and share the presentation if anybody wants to read this later. I've also got a link to the paper, which talks about, or a paper which talks about this in much more detail, which is quite useful. And then again, this is just an example, just a page from a database platform I'm working on, where we're actually exposing these links, explicitly exposing these links to other objects in the database. So this is a site, and we have all of its general markers. And here we have a spatial relationships. It falls within the extents of this map sheet. So that's effectively an emergent, a discovered geospatial relationship that was discovered when we ingested it. It turns out it's the geospatial database backend basically highlighted that. It makes connections with, so these are effectively its relationships developed from the point of view of this object, looking out at other objects, current location, various objects have been found there, and then received connections from. These are connections that talk back to this object from other objects in the archive. There's a visual item related to it. There's a document which documents it. There was an event that happened there, and so on. So many systems won't foreground these relationships. We were doing this just as an experiment to see what it looks like, to see the kind of things that CIDOC-CRM can make apparent. Okay, so I think that is basically it. I apologize if I went very quickly there. I was concerned a little bit about time, as I think, as Ida, you said you gave me 20 or 25 minutes.
Yes, you have still, if you would, we're now at time for 5 minutes questions, but if there are things that you want to wrap up, a minute or two should be okay.
I think that's it. I hope I've covered everything. Hopefully much more of this will become clear when you do the practical exercise.
Practical, exactly.
Later on. I think the things will start to make sense, and when you see that later, it might even be worth, I don't know if I could share this quickly, that people could even refer to this later.
If you can, if you're happy to share
I can
your
give you a Google Drive
presentation,
link to it.
and exactly, then I can share the link with everyone and put everything in one place.
Great.
Yes.
I'll do that, and hopefully this will then things will start to ring a bell and the connection will start to form. And then I've also provided some further reading, some of the things I've referred to in this talk, and some further reading, which I think are some quite useful papers and documents for those wanting to understand more about the CRM. Okay, well, thank you. And if there are any questions, then please.
Thanks very much, Anton. So yes, if there are any questions in the room, I see that there is one question in the chat, Anton, from Mary. Mary, do you want to unmute yourself and ask your question?
Okay, so please find my...
Good morning, everyone.
Yes, good morning.
Thank you for this opportunity. I so much appreciate it. My question is that, can CIDOC-CRM be applied to provenance studies?
To
provenance studies in an archaeological site.
Absolutely, yes. So there is the core CRM already has many properties which deal with provenance, but as I said, primarily focused to the museum side of things. And then the CRM Archeo extension to it actually goes right down to the into the excavation, basically, in a very, very detailed manner. So I think if you look at, when I shared my presentation, if you look at the links that are provided on the extensions page, there's a link to all of these standards there. And it's very, very detailed for excavations.
Thanks very much, Anton. There is a question. There's a hand on. Abu Bakr, do you want to unmute yourself and ask a question, please?
Thank you very much, the moderator. Good morning. Good morning, everyone. It's a fantastic presentation from the presenter, and I want to first give my own inputs about how archaeologists, the data collected by archaeologists, have been in my own part of the world, here in Nigeria. I believe the majority of data collected by archaeologists here in Nigeria, some of them end up in not a proper way of how it's being managed in the either museum and archive, whatever so the storage facility may be. And now the question now is, as CIDOC is a kind of a model of how one can also manage this particular data. I want to ask, is there a way that someone can use CIDOC in order to manage or to mitigate the chaotic data collected by archaeologists in order to manage them to a certain particular way that it's going to be minimal, so that there will not be a kind of chaos in the storage facilities.
Okay, sorry. So if you get you're asking about managing things in storage facilities and in archaeological storage facilities.
I was talking about data collected by archaeologists.
Yes, yes.
Which they end up in either museum storage, yes, or any other storage, either private museum or the public museum.
Yes.
So some of them, the data are, many. They tend to be many sometimes, and the management of those data end up to be chaos in the storage facilities. So here is my question. Is there a way CIDOC can actually use in mitigating or reducing this particular data collected by archaeologists in order to actually fit in and be a kind of manageable size in the storage facilities, e.g., for example, the museum facilities?
Well, I think if I'm hearing you correctly there, I think the thing there is, yes, CIDOC does have both in the core model and in the extensions, there are opportunities for I'm going to be a bit generalize a bit here. There are opportunities for managing both the data, the provenance of things, the provenance of data, and all of the paradata, i.e. everything about how the data was collected and where it is and what forms it in, is all that. So it offers those opportunities, and there is no reason why it can't be used to manage those across multiple, as I said, if I get your question correctly, across multiple institutions and across multiple platforms. But yeah, obviously the thing there is finding the appropriate systems which implement. The CIDOC-CRM itself is not necessarily a system. It is a means of modeling data. So one would have to find an appropriate system in order to do that, which implements CIDOC-CRM. In the case of MASA and MASM, obviously Arches. I can't think of any other easily available systems out there which do implement CIDOC-CRM, other than Arches at the moment. Because most of them have been custom developed. But yeah, I hope I got your question. I hope I answered your question right there.
Okay.
Yes, I think, Abubak, if you can stay on and see a few of the case studies that we're going to show after, especially using Arches as a database that use CIDOC-CRM ontologies to manage data, then it might answer, you can see it kind of how it can be used in a few examples. But yes.
Okay.
Thanks, Anton. We have another question from Ghaffar Ibrahim. Ghaffar, do you mind sorry, unmute yourself? Thank you.
How are you? Fine. I think I have a question in regards to the CRM and their extensions. Are they open or proprietary systems? And the second question regarding the migration of the data when things become obsolete. Thank you so much.
Okay, so firstly, yes, they're all open, and in fact, even the working group which develops the standards is also open and open to participation, and so is in fact the mailing list on which these the whole model has been argued for a number of years, and all of the messages, and that is all open and available. So one can also go back and look at how the various classes, properties, and extensions and that evolved. And then secondly, for the migration side of it, I mean, to a large extent, this is exactly why we are using a system like CIDOC-CRM, is that, or an ontology, is that it then allows us to, that in conjunction with various effective data formats such as RDF and semantic web technologies, allows us the ability to interchange across platforms, to back up in kind of platform and system agnostic manners. And in fact, we can even map CIDOC-CRM out into a rich text file or a spreadsheet. So yes, it's all open, it's all interchangeable. Obviously, it requires some work. You know, it's all interchangeable and open is a very easy statement to make, but yes, it is. It is.
Thank you. And one last quick question. Thomas, were you? Can you unmute yourself and ask your question, please?
Okay, thank you. My name is Thomas. I just wanted to ask a simple question about the extensions, the identifiers, and the appellation. I really wanted to know how long do they extend and how further do they go? Thank you.
As in what you're saying, as in the maximum size that you can use for an appellation.
Yeah, exactly. Thank you.
Well, that really depends on how it's implemented on a particular platform. You know, I'm not sure what the arch is. I'm sure anybody else in this could tell us what the arch's limit is, but it depends on how it's implemented. But I don't think that's really a factor anymore. It used to be when we were dealing with very constrained systems and low power computers and minimal storage. I really don't think that's actually a factor in any modern systems.
Yes, I agree.
Thank you.
There are no limits. Okay, thanks very much, Anton, for your presentation and